All right, hi everybody. It's just me today. Kay's out of town. So announcements for the day. First, the class is under a lot of revision right now, so sorry for any rough edges, like the textbook chapter not being up to date yet. I'm changing all the things I've wanted to change for a long time, so you're the guinea pigs, but it'll be good. After this lecture, you will know everything you need in order to do Project Zero. This is a totally new project, never been done before. We're still ironing out some rough patches. We're going to try and get it out hopefully tonight, but definitely by early tomorrow. It'll be due next Tuesday, and my recommendation is this week after you're done with the worksheet and you know how to do all the lists and sets and maps problems, start working on this project once it's out. Don't wait too long. Like, you don't want to wait till Monday to start unless you're very good at Java already, because it won't be very fun. There's actually, tentatively, I want to have two versions of the project. One of them is scaffolded, and the other one is much more freeform, the hard mode version. And if you're somebody with a really strong programming background, you might find that one fun. I'll talk about this project later. Another thing is, I said I was going to talk about packages today, but we're going to do that Friday instead. And so I'm going to let Kay talk about that, or maybe I'll do the beginning of the lecture. Also, you may remember there was this weird compilation issue that we had last lecture, and I think it's actually an IntelliJ bug that they're not caught up to Java 25 fully either. I won't demo it right now, but if you're curious, come ask me later. All right, those are our announcements. Any questions about announcements? Okay, let's get going. So today we're going to be talking about lists, arrays, maps, and references. And I'll start by continuing our journey into lists that we started last time. So we came up with this code here, which is more verbose than its Python equivalent in the sense that, you know, I have these imports up top that make me not have to type these long names. And I have to say the names of the different, I have to name my variable, I have to say what type it is, and I have to instantiate it. And in this case, we talked about the distinction between an abstract data type, like list, and a concrete implementation, like array list. Okay? And then again, as we'll see as we work through Java, often things are just a bit more verbose, and they're about to get a little bit more so. So this code will work. I can actually run this, but nobody would write Java code like this now. And one of the reasons is that, as we'll see, if we try to get back an item from the list and stick it in a variable, it won't work. It won't work well at all here. Okay? So that's our setup. We got here. We want to modernize the way that we will work with lists in Java. So in Python, if we wanted to retrieve from a list, and remember that's where this will fall apart. In Python, if we want to retrieve from a list, we just use bracket notation. We go to L and we say, give me 0, and it gives you back the 0th item. In Java, it's not quite so nice. Instead, we have to call a function called get, and we'll say, L, hey, please get me the 0th item. So it doesn't have that really nice bracket notation like you're used to in Python. Here, if I print it out, this will work just fine. But where we'll run into trouble is, what if we try to store this result? Like I say, string x equals L dot get 0. If I do that, it won't work, somewhat surprisingly. It won't compile. We get this error that says, required a string, but you gave me an object. Okay? So what I'm going to do is go into IntelliJ very briefly and show you this fact. So if here, let's make this larger. Okay, so seems like a very normal thing to do. String x equals L dot get 0. It yells at me and it says, squiggly line, that doesn't work. And the error is, if we zoom in, that you're supposed to be giving me a string, but actually you gave me an object. So there was a way to fix this before 2005, of course, but this just isn't how Java code is written anymore. And you can see that here because IntelliJ is freaking out. It's like, what are you doing? What are you doing? Like, all these lines are highlighted. These are warnings because I'm doing something strange. So in modern Java, which I showed at the very end last time but didn't explain anything, in modern Java what you'll do is you'll actually specify the type for your list. You'll say, this isn't just any old list. This is a list of strings. And the way you do that is by adding these little angly braces. And when I do that, you'll see this highlighting go away. And that's because this warning here, this was yelling at me, raw use of parameterized class list. You're doing something strange, basically. The fix to that is to say what type of list it is. Okay, and you'll get very used to this. There's one more thing that it's still yelling at me about, which is I say new array list here. What do you suppose I might do over here? That's, I got to fix. Someone who has not seen Java before. Or you have. Yeah, what do you think? Yeah, we could do that. And we could say string, for example. That's not what you were going to say, but okay. And that's how it was between 2005 and 2011. Then at some point in 2011, they said, you know what? Why do we really need to make people do this? So we'll just make you do the braces. There's a little funny, kind of a historical accident that we don't put string anymore because it gets inferred automatically. And now we're in good shape. Okay, what's this one yelling about, though? Ah, right, okay. Well, that's just telling me I could say get first. Okay, thank you, IntelliJ, but I'm not going to do that. And now that I've done that, my code will work just fine, and I can get back this item. Okay? Any questions about what I did here, other than, okay, it's just some syntax thing? Okay, it's not the most, oh yeah. You could do it the old way, and it will run, but I don't recommend it. And we'll talk about why in a sec, yeah. Object, yeah. Okay, so the question was, what if I went back to the old school way and I said object X? Would that work? Absolutely. And that's how you used to do it. And then there's another thing you could do called casting, which I'm not going to teach you. That lets you get the string out of the object. But it's not as nice. It's kind of old school way to write code. Okay, so this is the more modern way. Okay, so that's lists. A little clumsy, yeah. You could put string here if you want, and it's allowed. It's just not necessary since 2011. Oh, on the right. Over here, but not here. No, it doesn't. It's not defined. So if I take this away, it gets mad. I think what does it do, actually? I don't even know. It still considers it raw. Okay, so it's like you didn't do it at all. This is strange code. And by the way, this is not a class where I'm ever going to ask you questions like this on an exam. This is just obnoxious. Nobody needs to know this thing. I don't like to make you guys have to memorize strange corner cases. Just know how to do things. That's what I want. If this were a compiler's class, maybe we would do those things. Okay? All right. Another thing about Java lists since 2005, when Java 5.0 came out, is that a list that's created using angle bracket notation here, all of the items in the list have to be the same type. So I can no longer do l.add3. If I don't put this string here, technically a list could contain anything. But with this change in 2005, the Java designer said, this is what we recommend. Lists should be of one type. This will no longer compile. So this is allowed in Python. It's totally normal. But in Java, if you're doing things in a more idiomatic, modern way, lists don't have multiple types. Okay, so going from Java 4 to Java 5 20 years ago meant if you went along with the program. I mean, the old code still works. But if you adopted to the new way of doing things, you couldn't have multiple types anymore. Why might that be a good thing? What do you think? Because you lose something, yeah? Efficiency. I think there is an efficiency angle, but I think it's pretty small. Yeah? You know what you're getting out, and that's my main one. I think the main reason I like it is it restricts the choices you need to make as a programmer. This list can only be strings. And Java is a language all about setting restrictions, as we'll see later when we talk about the private keyword, or as we've seen so far with static types. Right? Java has these features that basically keep yourself from shooting yourself in the feet. And we'll see that all throughout the class. The basic idea is that having too much freedom leads to complexity because there's so many different ways of doing things, right? If you have 30 types of glue, then you have to know which is the right kind of glue. Maybe you make the wrong choice. But if you have just one very specific task and there's like a glue to do that thing and you know exactly what you're supposed to do, then you don't have freedom. Like this is the only wood glue, so to speak, right? And that complexity, it's just hard to fit in your brain when you're trying to write programs. Okay. All right, let's talk about arrays. So arrays are lists' cousin in Java. So there's a thing in Java called an array that you can think of as a restricted version of a list. So whereas lists have all kinds of functions like get first, get last, add last, etc., arrays have only a very limited set of things you can do with them. So a few things that I can tell you about arrays. One, when you make an array, you have to say how big it is in advance, which already is a pretty big deal, right? Like lists in general, it's nice to be able to append to them, but an array is fixed size. So once that size gets picked, it's set forever. And the syntax to do that, so when I declare a string array, it has special bracketing notation. So instead of saying list of string, this is a string, and then these two brackets basically say this is a sequence of strings. And when I say new string 5, what it will do is it will create 5 little places where strings can go, and we'll talk a little bit more about that in a bit. And then when I want to assign things, now you do get this nice square bracket notation like you have with lists in Python. So I'll say x0 equals a, x1 equals b, and so forth. Now arrays, they don't have methods, so there's no like max or min or whatever else. You can get their length out, which I'll show you in a second, but they don't have any methods, unlike lists, which have all kinds of methods, like get last, as I mentioned. Let's go see a little visual demo here of an array. Let's see, I guess that file doesn't exist, so we'll make it. Okay, 1 sec. Okay, there we go. File new. Let's do a little array demo. Okay, and again, I'll tell you what package means soon. And I'm just going to do void main, and we'll do string x equals new string 5. And we'll do x0 equals a. And I'll do x1 equals b. Okay. So when I set a breakpoint here, and we'll learn about these a little later, I can actually stop my program as it's running. And I want to stop here. There's a visualizer built in that I hope you'll use when you get to project 1 after the particle simulator, where I can see that after this line runs, I basically have these 5 little boxes that are created in advance where strings can go, and then I could put them in the boxes. Okay, so unlike a list, which can grow, this has pre-assigned boxes where things can go later. Any questions about this? Yeah. So if I wanted an extendable list, that's actually going to be one of the main themes of like, where does the list come from lectures 5 through 8. So we'll cover it across 4 hours of lecture. Yeah. Oh, sure, I can put whatever I want. So, right, yeah, I can put however much stuff. That's fine. It's just that list item, when it gets added, oh, I didn't have a semicolon. Okay, fine. Okay, there we go. All right, so we go here, here, and then when I do the visualizer, this last line, it just puts this long string in there, and that's fine. What's really happening, as we'll see in the second part of today's lecture, is this is actually a reference to something else. So you might say, that seems weird, and the string isn't really, I'll save it for when we get to that. Okay. Yeah? I'm not talking about subclassing today. No inheritance, sorry. Some other time. All right. So arrays, there's 3 different ways to define arrays. One of them is what I just did, where I say new int bracket and then how many boxes I want. If you want to, you can actually not put the number and then use this squiggly brace notation. And what this will do is it'll pre-populate the array with the numbers 1, 2, 3, 4, and 5. And how long do you think this array will be? 5, because that's how many spaces you need. Curiously, you can also use just squigglies without saying new int, just so long as you're also declaring a variable on the same line. So in other words, if y already existed, you can't assign it to some new squiggly braces. Squiggly braces are only allowed alone whenever you're declaring a variable. This is a boring language detail, but I mentioned it. So arrays have no methods, and you can get back their length using length. Okay. Quick philosophical, oh yeah, go ahead.
So in this situation, x and y were already...
Yeah, here x and y already existed, yes, right. So I didn't show their declaration. All right, so beginning of the day is not like exciting, but it's things that we should know. All right, we got maps next. Okay, so maps, for those of you who came from E7 and did not learn this, let me tell you concisely what a map is, and maybe it's nice for everybody else. So on the left, I have an example of a list in Python. I have the word fish, and I can append other data to it, and I can get back an item. I can get the 0th item. You can think of a map as a generalization of a list. So instead of having numbered items in the list, you have an arbitrary key type that can give you back an item. So here, when I say census equals, and in Python, this is something you may not have seen before, but the idea is I say, the number 32 goes with fish. I'm counting fish. There's 32 fish out there. There's 103 cats. There's 5 dogs. And each of these 2 lines here are appending a new box to this abstract object here, right? And when I want to get back the number of cats, I just go to the map and I say, could you give me the cat item? So whereas here I'm getting the 0th item, here I'm getting the cat item. And that's all it is. And these could be, as the key, it could be integers, it could be strings, it could be anything. It could be lists. That'd be a weird thing to do, but you could like look up from lists to something else in theory. There's some details there. Okay, so that's a dictionary. 95% of you have seen this, but if you haven't, that's the idea. And in a programming language, just a map in general, that's the word I tend to use because it's the most general term. It's just a collection of key-value pairs where you can take a key and look up a value. And all the keys, typically in these definitions, are guaranteed to be unique. They're also sometimes called dictionaries. That's what they picked in Python because it makes sense, because I could, for example, map strings to strings, in which case alpha would map to its definition, potato to its definition, and so forth. They're also sometimes called associative arrays, and you can read more here if you want. Okay. So I'm assuming you've already seen that, but if you hadn't seen it, that's the quick version. Any questions about the idea? Yeah? Yeah, so in Java specifically, there will be types, as we'll see in a moment. Yeah? Does indices start? Do they exist? I mean, depends on your mathematical framing. In some framings of an associative array, there is an underlying numerical index. In others, there's not. Depends on the context. In Java, there's no number when we build an array. You can't get the 0th item of a map in general. But a tree map, you kind of can. But I don't want to get into that. But someone asked earlier, what's the difference between a tree map and a hash map? But I would say a tree map has a sense of order, and a hash map does not. But this is for later. So let's see how we take this code and turn it into Java. And this is my last translation exercise, and one of our last just heavy-duty syntaxy things for our class. So this is going to be the flavor of the worksheet this week, as you'll be taking Python code and making it Java code in the primary worksheet. Okay, so if I wanted to translate this code over, what I need to first do is create an empty dictionary. And so the way I'm going to do that, or map, I'm going to say map. And here I'm going to pick two types. Okay, I need to do from something to something. So what type am I going from here? String. And what am I going to? Integer, it looks like. Okay, and we'll call that thing m. I call it census to map exactly. So map string integer equals new. And here I can't say map. I can't just say map. That's not allowed because maps are abstract. I need to pick a particular type of map. And there's many different types of map. I'll pick hash map. You could also pick tree map, but there are others as well. And then you'll notice I have not imported map, so I could say java.util.map, or if I don't want to do that, I can say let's import it. And remember in Java, when you import something, it doesn't make it newly available, it just gives you a shorter name. Okay, this is a minor fact of Java, but I find slightly fun. And then I'll say im, and I can't say that. That's what I wish you could do, but you can't. Instead, you got to call a method. You'll say input cat, comma, 103. And then m.put, oh, sorry, I got to make it a string. That's also not called m, it's called census. And also, I need to fix my quotes. Okay, cat, dog, and 5, okay? And then census, we'll do int numcats equals census.get cat. All right, that's the code. Any questions about that? I hope you're excited that you came here today to watch me type Java code. Okay, great. That's the translation. So at this point, we kind of covered the core syntax that I'm going to talk about in lecture. From here, we'll get more conceptual. We'll start building code together. It'll be more of a journey and less of a basic moves idea. So at this point, this week's discussion, you'll get a chance to actually build list sets, maps, array stuff. You can work through the worksheet, which is on the site. Even if you don't go to section, you might find it fun. If you're already a Java expert, I should say the first 2 weeks of section are going to be kind of like, I already kind of know all this. After this week, it'll be more unfamiliar. There's also an exam prep worksheet that I think is, even these problems, this is just off the fall exam, and there's another one off the old fall exam. You might find these fun even if you're pretty good at Java programming. And the exam prep worksheets, the exam prep sessions, I should note, are drop-in. So if you look on the website, just to get this on the webcast, oops, wrong semester, there are these sections. We go to discussion section. Okay, I guess I can't only pick that one. If you look at the section types, there's some that are these exam preps where you can go in and work on these hard problems on a drop-in basis if you'd like. Okay? Yeah? So when I say Java expert, when I said this first 2 weeks, if you're a Java expert, if you've already taken a class where you have seen list sets, maps, and arrays, this probably all feels very familiar other than maybe smoothing things out a little. Yeah. Hey, kiddos, did you want to give out the thing for the day? You don't? Well, give me the thing. All right. My kids are right here. Do you want to say hi? Can I take one of you out? Do you want to say hi? Okay, they're just giving me stuff. Well, after class, you can see them. All right, what we got is two things today. One, this is a tie. I wore this to my friend Brian's wedding approximately 11 years ago. Let's see. What? I'm gonna go like this direction. I'm just gonna throw this bad boy. Woo! All right. All right. And then we also have here a Nincha. You guys know, you call it Miffy, right? Okay, here we go. Nincha. Okay, hold on. I'm gonna go to the back of the room. Here we go. I'm going for you. Okay, here you go. Okay. Please enjoy the Nincha pad. Okay, thank you. I don't know if it's from the Netherlands or not. Did we get that in the Netherlands? Did we get that in the Netherlands? Yeah, it's from the Netherlands. Okay. Nincha, the pad. I gave it to someone way in the back. Do you want to meet her? No, you don't. Okay. Well, I gave the tie. I threw it. I threw it. Here, can I? No. Okay. All right. Great. Okay, let's talk about memory. So right now, my wife, she had to. Oh, in the Netherlands, fun thing. When you go to the doctor, they say take some Tylenol, and you'll be fine. And so she had an ear infection that was so bad that it eroded her eardrum, and she had to get her eardrum repaired. Today, she's getting her ear inspected by American doctors. Thank you for fixing my wife's ear. And these kids are off school. So anyway, all right, let's talk about memory. Okay, I have a question for you. I have not taught you how to solve. This is an experiment. I'm hoping that we can make it just work with a QR code with nothing on the screen other than that. But if you can't scan this QR code, let me know right after class. But this is doubling as attendance today. I don't know how to do attendance for so many people. So I'm going to try this. But if many people could not scan it for some reason, fine. Then I'll record you otherwise. So you guys don't know how to answer this question, but I want you to try. I also would like to find my phone so I can do this too. Do you guys have my phone? Do you have my phone? No. Okay. You can chat with your neighbor, and you don't have to get this question right in order to get the attendance credit. Is it working? It's not working? No. What's it doing? No link. Okay. Well, here we go. Shows up for me. Okay, I'll say. It seemed like a good idea. It is working? Okay. Oh, I see. Hold on, I know what to do. Okay. As I said, it's all new. Things are new. I would love my telephone. Yeah. Oh, I don't know. You have to play something else. Okay. Strange. All right. For whom is it not working? Some. Okay. I'll get you after. Okay. Find my device. Oh, there it is. Okay, good. Okay. Okay. Cool. All right, so I haven't told you the answer. I'll tell you in a sec. Okay, I got another one for you. This is the second one. So this is integers. If you only answer one question, that's fine. The assumption is you're not sending these links to your friends, please. But I guess you could, but that's super lame. Okay. And again, I have not told you how to solve this problem. That's the point of the lecture from here. But I want you to give me your best guess. Okay. All right. So, you guys had some decent instincts on average. All right. So it turns out that on the left, that the change does actually follow the method call, does actually follow these, like these assignments do actually affect the walrus A, but in the integer case, it doesn't. And what I want to do today is build a very good foundation so you know exactly why, because it's easy to have a more complicated view of the universe than necessary. So I'm going to start with a visual picture here so you can see how this all works. Okay. And I'm going to step through this more in detail in a moment, but the basic idea is that when I create this walrus object, okay, I skip forward a bit, a walrus gets created, and here it is. When I say B equals A, the mental picture you should have in your mind is that we're pointing at the same walrus. And I'm going to talk in more detail about exactly why that is. But now the key idea is that A and B are the same object. When I say B equals A, no new walrus gets created. We're just giving another reference to the same object. Then when I see b.weight equals 5, there's only actually one walrus. That's the idea. By contrast, when I get down here, when I say int x equals 5, the number 5 is like in the box by itself. There's no arrow pointing at a 5. It's in the box. When I say y equals x, there's a new box that also has a 5 in it. And when I say x equals 2, just that changes. Okay? Now I'm going to, again, go through this in much more detail, so I'm not even going to take questions here. But that's the picture. A and B were the same walrus, but the numbers were different. Now, this is not how every programming language has to be. You can make Java weird, and Java weird would be exactly the same, except that y and x would actually be the same integer. Or you can make Java super weird. And in this case, when I said b equals a, it does make a copy of the walrus. There's no reason it absolutely has to be this way. That's the way the Java designers picked, and what I think makes sense. But you could pick something else. Okay? So let me tell you about bits then. This is going to be 61C Lite. The idea is that your computer, when it has stuff, it stores it in memory. And all of that stuff that is stored in a modern computer is stored as a sequence of ones and zeros. And 61C will go into lots more detail. But the basic idea is that the number 72 usually is stored, for example, as 01001000. And if you take 61C, you'll learn why that sequence of bits. But I'm not going to tell you. The number 205.75 is stored as 64 bits that end with these. The letter H is stored as 01001000, which is the same as the number 72. That's capital H. True is often stored as 7 zeros and then a 1. And the basic idea is that the Java interpreter, if you took 61A, at the point when it's doing the interpretation, when it has a certain type in mind, it interprets the bits differently. So if the variable is defined as one of these 8 types, like byte, short, int, long, float, double, boolean, char, it has an exact mapping it has in mind. When it sees 7 zeros and then a 1, it says, oh, that's a boolean. Okay? And again, we're not going to talk about these exact representations in 61B. I just want you to know they exist. And then in 61C, you'll learn what they are. Okay? And so I'm not going to talk about, like, well, couldn't this really just be 1 bit? Sure, but it's not for us. Okay? Now, I should note that the precise representations vary from language to language, machine to machine, but all things in memory are represented as bits. Okay? All right. So when you declare a variable, and this is what I call the memory box model. I invented it. It's a little bit slightly wrong technically, but it's conceptually exactly what happens. When you declare a variable of a certain type in Java, it is as if the following happens. Your computer sets aside exactly enough bits to hold a thing of that type. So for example, when you make an int, ints are always 32 bits. Doesn't matter if it's the number 3 or the number 1,000,000 or the number 2,000,000,000, you get 32 bits. You don't need them all necessarily, but that's how many you get. When you make a double, you get 64 bits. And then Java will have this internal table that says, well, each of these variables corresponds to some location. And again, this is not quite true, but you can pretend it's true. Java does not put anything into these boxes that it's reserved for you. And for safety, Java won't even let you access it. So unlike a language like C or C++, where you can declare a variable and say what's in there, just as I can walk up and pick a cardboard box from the ground and like peer inside of it, there's things in there. In Java, it's not allowed. When you create the box in Java, it's undefined. It's like a black hole. If you tried looking, it won't compile. Okay? So if I define x and I print x, it says x undefined and won't compile. So in other words, when I make x, I get 32 bits. When I make y, I get 64 bits. When I say x equals this giant sequence of digits, What's actually happening under the hood is the box gets filled in with all these bits with why you get these bits. Any questions about this? Now again, on a real machine, this is a simplification of what actually happens. In 61C, they tell you what actually happens. But this is, for all intents and purposes, accurate. Yeah? Yeah, Boolean seems like it could be 0, 1. I think typically we were thinking about it as 8 bits. But I think in Java it actually does take 8 bits. But I haven't looked at Java 25. It's possible they compress it. Yeah? What's inside? Well, okay, so in reality, there's actually registers and all this other stuff I haven't told you. So there's not really an answer to that question, because this is a slight fiction. But it's in the memory box model. Okay, so all models are wrong, but some models are useful. This one's useful. Okay. Now what I'm going to do is this box notation, I'm going to start writing things what I'll call simplified box notation. I can't read this. Like, I know if I spent some time with it, I could figure out, oh, this sequence of bits is just negative 1.4 billion or whatever, because I know it's a 2's complement integer, blah, 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 things you haven't learned. But I don't care. I'm just going to write it like this. Okay, so rather than show the actual, like, true contents of my memory box model, I'm going to represent it just by its representation. So I'm going to put human readable symbols, but understand that really what's happening is Java is thinking about a sequence of bits as this number. So why is this useful? Why am I telling you this? Well, the reason is, for the puzzle I gave you, there's a very simple answer to what equals does. I call this, again, I made this up, the golden rule of equals. If you have two variables, y and x, and I say y equals x, all that you're doing is copying the bits from x into y. So they have to be the same type, because they have to be able to fit, and also Java will yell at you if they don't match. But when I say y equals x, I'm just copying the bits. So if it's an integer, a walrus object, whatever it is, I'm taking whatever was there, and I'm putting it in the other box that has a different name. Okay? So if I look at this example from earlier, when I run this code, just this part, and we'll get to the walrus in a bit, I declared these two boxes. Okay, now, because this doesn't use my memory box model, you don't see y yet, but imagine that it's there, and it's 32 bits. When I say y equals x, I'm just going to copy these 32 bits into that box, and instead of representing it as 0, 0, 0, 0, 0, blah, 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 1, 0, 0, 1, I'm just putting the number 5, and that's it. Okay, so the golden rule of equals is we copied the bits. So what about those arrows? Okay, we'll get to those. All right, back to, nope, not that. All right. My daughter, who's here, is named Ilsia, so today I played music by Ilsia. But it's different Ilsia. My daughter's not this Ilsia. But anybody, any Tatars here? No. Okay. Anyway, wouldn't expect it. Yeah. All right. Okay. Let's talk about reference types now. So this is the other thing you need to know. All right. So in Java, there's these 8 primitive types. We've only really used int and double. There's others. I guess we use char a little tiny bit. Oh, have you? Maybe not. We don't really use most of them. But the key ones that we've seen so far, int and double, and these other ones exist. Booleans and chars you'll also use. Now every other type, whether it's walrus or planet or dog or whatever else, or an array, those are all what are called reference types in Java. It's the 9th type, like an omnibus type for all references. So when you create an object using new or otherwise, like a dog or a walrus or a planet, what Java does is it creates a box of bits for every instance variable and fills them with a default value. Now that's different than variables. When I say int x, I get a box and there's 32 bits and it's undefined. When you instantiate an object, like I create a dog or a walrus or whatever, even if I don't set the data, it always immediately fills it with some default value, and then the constructor will go through and fill it with some other value. Here, the memory box model does match, or the visualizer matches my model. So when I say walrus a equals new walrus, the first thing that happens is we get 2 memory boxes, one for the weight and one for the tusk size. And they're filled with a 0 by default. So you birth the walrus, it's got its default zeros in there, and then you say, hey, you're not size 0, and you have bigger tusks than that friend. Your weight, it's going to be 1,000, and your tusk size, 8.3. And then it's born, just like you were. Okay? So all your properties were 0 at first, but whenever you were created, then we filled them in. That's what I've heard. I'm no expert on theology, but this is what I believe to be true, having taught this class 14 times. Okay? Are any questions about that? Yeah. So an interesting question is, what about the capital I integer class? If I have time at the very end, I'll talk about it, but I'll save it for now. Yeah. Yes, that's an interesting question. So in an array, is every box its own instance variable? They don't usually use that term. And the length is also not considered an instance variable. It's just its own thing. Yeah. I was actually experimenting with that today. I was using something called the reflections library, trying to ask an array, like, well, what do you got? And I was like, I don't have anything. What are you talking about? Yeah. Mm-hmm. Yeah, so if you create an array of size 5, it'll, as we'll see in a little bit, it'll fill them in all with default values. And then you can fill in from the middle. That's fine. You can leave the 0 and the 1 empty and fill the others later. Yeah. So is a string like an array list? So we don't actually know so far in class how a string is implemented, but indeed there is an underlying character array that's fixed width. And for that reason, strings can never be modified in Java. And other reasons. All right? Okay, so that's what you get. Whenever you run this code, you get these two boxes. One's 32 bits, one's 64 bits. So the walrus itself is 96 bits plus a little bit of overhead that we won't describe. Okay. So if you wanted to think about memory as a long sequence of bits, like just a book, or a piece of paper with all the bits in it, which is a reasonable way of thinking about it, think about it this way. So here, there's all these zeros that were just laying around. I put zeros, that's what happened to be in memory beforehand, right? You just turn your computer on, whatever. So then what happens is, whenever you create a walrus, it finds some place for the walrus to live. Here it is. And then it puts the weight here, the first 32 bits there. And then there's the blue tusk size. And the blue is longer because doubles are 64 bits. And so my just simple picture is that the walrus is only 96 bits. These 32 green bits, these 64 blue bits, and there's actually a few extra bits that have to do with bookkeeping that aren't important for us. Okay? So that's what you get. All right? Now, what new does, if you think about new as like a function, kind of, it's not really. But when you say new walrus, it goes, finds a place for the walrus to live, births the walrus, fills in its variables, and then it says, hey, this is where I put the walrus. I put it in location 2.384723423 bits. Now, I mean, it's an arbitrary, weird number. It wouldn't actually be that exactly, but the basic idea is true, that we get a specific location. And so new walrus, it creates the walrus, and it returns the address, which will be important when we start assigning variables. Okay? Let's talk about variable declaration real quick, and then I'll tie back this together with creation. So when we declare a variable that's any reference type, so planet, walrus, array, anything, Java will create 64 bits no matter what type of object. So we saw a walrus is 96 bits, right? It's too big to fit in this box. And we'll fix that. That'll be fine. And the basic idea is that when you first create this box, it's going to have undefined value. And in that box, we can either put one of two things. One, we could put null, which you can think of as just all zeros. Or we could put the location in memory where the walrus is. So for example, we could take this number, this is the location of the walrus, and put it in these 64 bits, because computers these days are 64-bit addressable. That's how many bits you need to refer to the location of something. And so when I say some walrus equals new walrus, if we think about, again, the golden rule of equals, we create the walrus, it's birthed into existence, then we return its address, and that address is how long? 64 bits, and so we say some walrus equals, we're just taking those 64 bits and copying them in. It's the same exact golden rule of equals. Now I don't know about you, but I find it annoying to read an address like this and then go look at all the memory and see what's there. So what we'll do instead is use another simplification of our box notation, and instead of writing out the address, which would be fine, like this is where it is, we'll instead draw an arrow. It's shorthand for this is the address, and then you go to memory and see what's there, and it's drawn. Okay? So I call this box and pointer notation, probably somewhat similar to environment diagrams you've seen in the past. Or any questions? That's the basic memory model I want you to have in mind. And we're going to spend a ton of time with this Friday, next Monday, and next Wednesday when we build lists. Okay? All right. So just as with primitive types, I want to reiterate, it's still doing the golden rule of equals. So when I say walrus A, we get a memory box with 64 bits. What's in it initially? Not null, actually. It's undefined because it's a declared variable. You only get the default value when you instantiate an object. Sorry, it's just an annoying detail. But when I say walrus A, it's undefined. When I say A equals new walrus, how many new memory boxes get created at this point? What do you think? So I say A equals new walrus. How many new ones get made? I heard some whispery twos. It's 2, yeah, so 2, 1 for the weight, 1 for the tusk size. What does new walrus return? An address, a 64-bit address. And what happens to those 64 bits? They get copied into this box. When I say walrus B, how many new memory boxes get created? 1, and how much bits are in it? 64, and what's in it? Undefined. Okay, there it is, it's undefined. And then when I say B equals A, I'm just going to copy the memory bits here, these 64 bits there. Oops. All right. Okay. Yeah. How do you instantiate? To a default value. If you want to say walrus B, if you wanted to set it to something, you'd say B equals null. Yeah. So you have to explicitly set nulls when declaring a variable. And you only get the default value when you instantiate an object. Okay. All right. Oops, let's fix it. Parameter passing. Okay. So, parameter passing. All right. I want to note that often we have functions, and you give them things. And it turns out that the golden rule of equals also applies to parameter passing. So, for example, this average function, when we call it, you can think of it as there's secretly like a little hidden code thing that happens here, where we say basically, before this ran, A equals X, B equals Y. Like that happened here. Like that was I'm gonna put that there. It just occurred to me as I was getting ready to give the slide. So basically the idea, remember the golden rule of equals is given variables B and A, we're just copying all the bits. And that's also the same idea. When we pass parameters, we're simply copying bits to the new scope. So I'm taking 5.5 and I'm passing it in, and it's like implicitly like A got set equal to X, where X is in this main context. Okay? Yeah? Oh no. Why did I put string args here? Because I forgot to get rid of it. That's why. That's before Java 25. You can have it if you want, but I'm erasing it. Okay. All right. So the basic idea, if we think about this code running, when main runs, first we get this variable. Oops. Okay, there we go. Okay. When you run this code, this line of code says X is 5.5. This right here will create a memory box of how many bits? 64, and it'll put the number 10.5 in it. And then here, when I say double average equals average, we're going to go up to this function up top, and it creates 2 new memory boxes called A and B, and it's just copying the bits. And because these bits, because these are primitive types, it's not copying an arrow, it's just copying a number. Okay? All right. So this is also called pass by value, by the way. And Java's all pass by value. There's another kind of passing called pass by reference that does not exist in Java at all. Okay? All right, so the golden rule summary. That's what you gotta know. There's 9 types of variables in Java. There's the 8 primitive types, and there's the 9th type, which is objects. When we draw our box and pointer diagram, it's gonna be references to an object. These will be arrows, and the references, they can be null. In box and pointer notation, each variable is a labeled box, and the values are shown in the box. Addresses, because it's useless to read an address without seeing all the things that could be in them, we'll put an arrow. And the golden rule again is B equals A copies the bits, and that also applies to passing parameters. It also copies the bits. Okay, let's do one more of these questions for the day. And then I'll have one more thing I want to tell you about after. Okay. This is my test to see if the lecture was too boring. And again, you don't have to get these right, and I will never look at your individual answers. You can talk to each other, by the way, if you want. Okay, I'll wait for a few more answers. Okay. How'd we do? Oh, we did bad. We did good. We learned, we got about 78% right. That's pretty good. Okay, so the correct answer, if I do a quick demo of this for you, but you can also run this yourself later. If I run this code, let's step forward a bit past the part where we create the walrus. Okay, so in the main frame, we have walrus is pointing at this object, x is 9. When we call do stuff, there's two new variables, w and x. So these bits will get copied into the w box, and these will get copied into the other variable's x box. All right, there you go. So there's actually two different variables named x. So that doesn't actually change things. In this frame, this variable called x and do stuff is totally different than this x. So indeed, the answer that 78% of you had is that the walrus weight does change, but the x does not change. Now, I don't want to take questions about it, but I will say that if that didn't make sense or you got it wrong, come back and look at the link on the slides. Okay, I got one more thing I want to tell you about pretty quickly that I think is just kind of a fun aside about 2D arrays. This is sort of a bummer of a thing done on lecture because it's distinctly uncool or new, but maybe it'll be cool. All right, so it's possible to create multi-dimensional arrays. For example, I could say int bracket bracket x equals new int bracket 4 bracket, and that will create a new array x of length 4. And then in each entry of x, you can hold the address of an array of integers. So instead of an array of integers, it's an array of integers. Two quick little examples I want to show you, and the main reason I want to show you this is to emphasize that two-dimensional arrays are kind of fake. Okay? So I want you to play around with this after lecture, because I think, well, we're out of time. Well, we'll be out of time in a minute. And also, it's probably boring to watch me run too many examples. So when I create this code, what I want to observe is that this Pascal's triangle object points at an array of references to other arrays, and that it's not really one concrete object. It's an array that points to arrays. I will note that there is also the ability to create a two-dimensional object all in one line that does the same thing. And then the very last thing I want to mention that it's syntactically possible, and which you'll see in Project Zero, is that you can create a matrix, something with fixed widths and heights. But even if you do that, it's really just an array of arrays. OK, that's all I got for you today. So we'll end ourselves 30 seconds early. And if you want to meet my kids, you can come up here. And if you could not do attendance, come up and I will take your name on paper. That will be my approach. Yeah, come on over.
How do we take attendance?
The attendance was if you did those questions on your phone.
Oh.
Yeah, so you're in. Also, you only need to have done one of the questions for attendance to count.